And it is time to get started. Welcome everyone to Digital Earth Academy ICE. And for those of you who guessed that this was Antarctica or the South Pole, you are correct. Bravo, well done. Now, we're about to get started and about to hand the program off to our research associates, Bob Reynolds, and our global pilot, Asa Erlinson. But before we do, I have a couple of housekeeping things to take care of. First of all, I want to acknowledge that the Denver Museum of Nature and Science is on traditional lands of the Ute, Arapaho, Cheyenne, and Oceti-Chacoan tribes, and that lands all across the planet are and have been stewarded by indigenous peoples. I also want to acknowledge that there are people here from all over the country, which is very exciting. We're so excited that you joined us today. Throughout the program, you'll have two different ways you can interact with us. There will be a couple of polls where you'll get to help decide where we go next. And then also we'll have the chat, and we'd ask for you to only use the chat to ask questions that you'd like us to answer or to answer questions that we ask you. We won't be answering questions until the very end. So if you typed in a question, I will be keeping an eye on it and I will watch for those questions and I'll write them down and we'll answer as many as we can, but you don't need to ask your question again. And so with no further ado, I would like to introduce Bob Reynolds and Asa Erlinson, who will be taking us on our tour all around the country. Let's see. Not this country, the whole planet. All right.
All right. Hey, Mitch. Yeah, thank you guys very much. Thanks, Mitch, for pulling the introduction here. And welcome everybody to our first rendition of Digital Earth Academy. And this is a brand new program from the Denver Museum of Nature and Science, and we're really excited to offer it. And I'm speaking to you from my home in Longmont. My name is Bob. I'm a geologist. I'm a research associate at the Denver Museum, and I work on the rocks of the earth and the climate of the earth. And it's a wonderful opportunity to share these ideas with you guys. And what we're going to do is we're going to have a tour of the whole world. We're going to be wandering around the world using a program called Open Space, which is very similar to Google Earth. And a lot of what we're going to do today, you guys can do at home using Google Earth. So I'll mention that a few times because we want you to be able to follow up on this program in your classes, in your classrooms, and at home. I'm going to start off with an introduction to the world. And we're going to be talking about ice, but the world, the planet is really a water planet. We've got a wonderful variety of water resources on the planet Earth. But I think let's see if we can pull up that gallon jug analog here. And if we put all of the water on the surface of the world into a gallon jug, if we sort of thought about it fitting into a gallon jug, so you've got to sort of imagine we condense all the oceans and everything else into the gallon jug. And then we ask ourselves, well, how much of that water is fresh water? And 3 little Dixie cups are fresh water, that proportion. And 2 of those Dixie cups are full of ice. So there's only 1 Dixie cup worth of water on the surface of the earth that is liquid and fresh and drinkable. And 2/3 of the fresh water on the surface of the planet is frozen as ice. Now I'm going to ask a question, and this is sort of an experiment that you guys can do. And I'm going to ask you, why is it cold at the poles? So you all know it's cold at the North Pole and it's cold at the South Pole. Well, why is it that it's cold at the poles? And I'm going to do a demonstration to show you why it's cold at the poles. And again, this is something you can do in your classrooms and you can experiment with for yourself. I've got a copy of the Earth here. That's a wonderful globe. It sits on my desk here in my house. And this is it's a sphere. You can see it's shaped like a ball. The Earth is shaped like a ball. And the top is the North Pole and the bottom is the South Pole. And if I use a flashlight, and I've got a cell phone here, which I know has a flashlight on it somewhere, and you guys are faster than I am at things like this, but bear with me. Here, I got it to work. So if the flashlight is the sun, it's illuminating the Earth. And you can see how the rays of the sun hit directly at the equator in the middle part of the Earth. And the rays of the sun are only very oblique up at the poles. That's the North Pole. And then here's the South Pole. The rays of the sun are oblique. They come in at a very low angle. The sun doesn't get very high in the sky. So the sun is very hot directly overhead at the equator and in the latitudes near the equator. But up at the poles, the sun comes in at a very low angle. There's not a lot of energy from the sun. And so the poles are cold. And that's where there's a huge amount of ice. So we're going to see ice up near the poles. So let's go over to Asa. And Asa is going to be giving us a tour of the Earth. And I've got to put my globe down here. And we're going to start at the Denver Museum. So for those of you who visited us at the museum, some of you have seen the museum. And this is what the museum looks like from above. We're looking at the roof of the museum where there's all kinds of solar panels. And we're going to see if we can back out from the museum and see what it looks like as we climb up, as if we're in a balloon or in a rocket. We're going to leave. That's the Denver Museum. You can see parts of City Park. There's a duck pond there. There's the zoo. There you can see all of City Park, and you can see much of central Denver. And now we're going to be climbing up, and you can see almost all of Denver. The South Platte River is going to show up on the left-hand side of the screen. And we're backing out. We're seeing the Front Range area, Denver and the surrounding communities. Now you're starting to see the mountains coming up. Those are the Rocky Mountains to the west of Denver. We're backing out, getting higher and higher and higher. Pretty soon you're seeing almost all of Colorado. We're getting higher and higher and higher. And you're seeing Salt Lake City. You're seeing the Midwest. You're seeing the Great Lakes. You're seeing the Pacific Ocean, the Atlantic Ocean. And now you're seeing the whole globe, essentially. And we're going to be starting our tour up in Alaska. We're going to go far north. Some of you might have been to Alaska. We're going to go up into the area around Anchorage, and we'll get ourselves started. So Asa's bringing us up into the white stuff up there are the snow-covered peaks. And we're just going to take a quick view at some glaciers, which are places where ice is actually flowing from these high mountains. And we're going to spend quite a bit of time talking about glaciers because ice is a wonderful material. It accumulates, of course, from snow. And we'll wait for the computer has to sort of catch up here. But you'll start to see the white stuff is the snow and ice. And the ice accumulates in the high mountains, particularly in northern latitudes. And it starts to get into enough volume that it flows. Ice is technically, it's a mineral, which is like a rock, but it's a rock that can flow, and it actually flows like almost like water, but very, very slowly. And these glaciers are essentially rivers of ice. And we're introducing you to some of these rivers of ice here in Alaska. You'll see they're flowing out of the high mountains. They flow down into the valleys, and they're actually very strong agents of erosion. The glaciers, which are made up of solid ice, are flowing down from the mountains. Every day they move a little bit, and they're carving these valleys. And here you're seeing them carve valleys in Alaska, but we're going to eventually get back to Colorado, and we'll see that they've carved some valleys here in Colorado, and we'll show you that ice is a very powerful agent on the surface of the Earth. Now, the way we've set up our program, you guys are going to help guide us. So we've got lots of places we can go, but we've got a way that you can help us choose where we go. And we've been studying the glaciers in Alaska. There's some very beautiful ones to look at. And one of them looks a lot like a puddle of taffy. And another one we've looked at looks a lot like a caterpillar. And so we're going to ask you now as a quick poll to choose whether you want to go to the Caterpillar Glacier or the Taffy Glacier. And I'll talk for a little bit here as you guys choose, but here every participant has the chance to indicate whether you want to go to the Caterpillar or the Taffy. And you guys just fill out the poll and take a little bit of time, take a couple minutes to fill out the poll, and we will decide where to go next. While you're filling the poll out, I'm going to keep talking about the force of ice. And in Alaska, we have a huge number of glaciers because we've got very high mountains, both in the Alaska Range and in the Brooks Range, which is up to the north. And these glaciers have been very active for thousands and thousands of years, but they're all melting. The surface of the Earth is getting warmer as the climate is changing, and the glaciers in Alaska and the glaciers all around the world are actually melting. So we're going to talk about that and the impact of melting glaciers on our planet.
And Bob, we have the results of our poll.
Wonderful. Looks like there's a desire to go to the Taffy Glacier. Is that right?
That is right. Pretty close, but the Taffy Glacier edged out, or the Caterpillar Glacier edged out the Taffy Glacier. Nope, what you said.
Taffy Glacier.
Taffy Glacier.
I see Taffy Glacier 155 and Caterpillar 110. So
that's exactly right.
We're going to go, you know what we might do is we might go to both, but let's go to the Taffy Glacier first. So Asa is going to fly us over. We're still in Alaska, and we're going to cross away from Anchorage, and we're going to be heading down towards Juneau, which some of you know is the capital city of Alaska. But we're not going to quite get to Juneau. We're going to stop before we get there and look at a place where there's a giant glacier that's coming out, and it's putting the ice right onto the coastal plain very near Juneau. And it's just coming into view right now. And this is called the Malaspina Glacier. It's actually two glaciers coming out. You can see on the left-hand side of the screen, there's two glaciers. The upper one is called the Seward Glacier, and the lower one is the Agassiz Glacier. And they feed out into this giant pool of ice. And you can see that it looks a little bit like a puddle of taffy. And if we zoom in just a little bit closer, Asa, you'll start to see a little bit more of the texture. And you can see what's happening is the ice is flowing out onto the flat valley there, and it's making that taffy kind of pattern. And it's a really cool pattern. You can see this from space. You guys can do this on Google Earth and home. You can see if you can find this glacier. It's called the Malaspina Glacier, and you can find it yourselves. And again, the ice is flowing from the north to south. Here we've got a movie of it flowing. You can see it. Look at, doesn't that look like taffy coming out? It's just pouring out. The ice is pouring out, and it's pooling up on the coastal plain of Alaska. And there's some really short rivers. Some of the shortest rivers in the United States are where the water comes out from this pool out into the ocean. So that's the Taffy Pool Glacier. Now, why don't, Asa, since a lot of people wanted to see Caterpillar, let's go see if we can find the Caterpillar too. Caterpillar is not too far away from here. Its name really isn't Caterpillar, but it looks a lot like a caterpillar, so we call it the Caterpillar Glacier. It's really several glaciers that have come together, and it's called the High Plateau Glacier area, and the glaciers look to me like a caterpillar. So here we're going to scoot down and look at these glaciers that are coming together. Again, rivers of ice flowing together. And the rivers of ice, each one has a what we call a moraine, or a rocky thing on the edge of it. And when two glaciers come together in their junction, these moraines join, and you get what we call a medial moraine, which goes, it's a middle moraine. So these glaciers, wherever two glaciers come together, there's a black stripe that gets formed, because that's the rock and the grungy stuff that's being carried on the edge of the glacier, and it comes together. Now these guys have these sort of ripples or rumples in them. And when I first saw these glaciers, I thought they looked like caterpillars. And do you guys think they look like caterpillars? You can tell me in the chat if you think it looks like a caterpillar. And Ace is going to fly around it for a little bit, but here you can see it moving. So this is what a movie of the Caterpillar Glacier looks like. And you can see it's got little stripes on it that are moving down. And those are actually landslides that fell on the glacier. So the little black things that are moving down are landslides, rocky material on the glacier. And we're running the video several times here. That's why it keeps doing the same thing. But you can see how it's flowing. You can see that this is ice flowing like a river downhill.
And Bob, we have in the chat, some people say that, a lot of people say it looks like a caterpillar. Some people say it looks like tree roots. Someone even said it looks like sushi or salmon skin.
Oh.
And we have people asking, if ice is a solid, how does it move like that?
Well, that's a good question. So we look at this and we see tree rings also. So those actually represent annual rings, and what it's moving like in pulses. So in the summertime, it moves a little bit faster. In the wintertime, it moves slower because it's colder. And the way ice moves, it's a solid. If you think about it, you know, an ice cube is solid, but if you were to squish it, it will slowly deform. Ice it's a solid, but it actually behaves a little bit like a plastic. When you squish it, it moves. And there's a lot of things that are like that. Actually, salt, which we think salt is pretty solid, but as a geologist, I can show you places where salt flows. We actually have salt glaciers in places like in Iran. There are salt glaciers. So many things that appear solid to us in our time frame, our quick experience, if you look at them over longer periods of time or geological time, they're actually like plastic and they can flow. So here we're getting these wonderful views of these annual little rumples on the Caterpillar Glacier in Alaska. And again, it's called the High Plateau Glacier. If you type in Caterpillar Glacier, you won't find it, but it looks like a caterpillar. And it does kind of look like ocean waves I see then there are bumps. I'm seeing people commenting on the shape of the ice. It's extremely rugged and it's a dangerous place. When you get up on a glacier, there's great big cracks called crevasses. It can be super dangerous. So when you climb on a glacier, you got to be really careful. And I've climbed on glaciers in Alaska and also in Iceland. So now we're gonna sort of back away slowly from Alaska, and I want to bring us back towards Colorado so that we can see some examples of the glacial activity right here in Colorado. And we're going to see as we back out from Alaska, again, this is the kind of thing that you can do on Google Earth. You can use Google Earth at home to do these kinds of things. And we're going to back out. You're seeing the Pacific Northwest, which would be Washington State, British Columbia in Canada. And we're going to now cross across the Western United States, and we're going to come down to Colorado. And we're going to, as we come back in towards Colorado, we'll stop the flight when we have most of Colorado on the screen, just so that you can get oriented. And many of you have looked at maps of Colorado and you've seen the way the state looks. Now we're coming down in, and we've still got Utah on the left. But as we come to about this point, just about now, that's the entire state of Colorado on the screen. And you can see the flat plains on the right, the mountains on the left, the deserts on the far left. And we're going to go down to an area called the Upper Arkansas Valley, which some of you might have visited. It's near Leadville and near Buena Vista, if you guys have been there. We're going to scoot down in, and just south of the town of Leadville, there's a place called Twin Lakes. And we're going to look at Twin Lakes, and we're going to see if there are glaciers in Colorado. And the answer, I'm seeing some questions in the chat about whether there are glaciers in Colorado. We've had some discussion about this because they're mostly little small ice fields. And the key for it to really be a glacier is it has to flow. And most of the glaciers in Colorado are so small that they hardly flow at all. And we've had some discussion about whether they really are legitimate glaciers or not. But if we look at the rocks of Colorado, and of course I'm a geologist, so I spend a lot of time looking at the rocks, we can see evidence of glaciers that used to be in Colorado. And they've melted. When the end of the ice age came, they melted. And today, all we can see are the valleys that the glaciers formed. And we're now located just south of Leadville, Colorado, and we're going to look at Twin Lakes, which is just coming up ahead on the upper left of your screen. So we're going to scoot up to that lake. It's called Twin Lakes because there's two lakes there. There's actually three, and that upper lake is a very interesting one. We'll talk about it briefly in a second. But if you look at this valley from the point of view of a balloon, if you're flying up in a balloon looking at the valley, I think you can see that it's got a super U shape. It's got a flat bottom. It's got these big lakes down at the bottom of it. And the big lakes have these big ridges of rock pushed up all around them. And these are moraines. And this is a valley that was carved by ice. So we're looking at a valley that used to be full of ice only about 10 or 11,000 years ago, so a few thousand years ago, this was full of ice, and the ice carved the valley. It literally broke the rock and carved the valley. Ice is extremely strong, extremely powerful. It's a beautiful thing to see, but the ice can break rocks, and we're going to see that in a second. So we can make a U-turn up here, Asa, and I just want to, as we make our U-turn in a U-shaped valley, that's a pun. See, it looks like a U-shaped valley. We're going to go down that U-shaped valley, and I wanted to point out, a little bit to the left. Yeah, I wanted to point out the extra lake down there, which is a really cool thing. So why would there be an extra lake up on the edge of this valley? See that little extra lake up on the upper left? And it turns out that a little pooch of the glacier made that divot up there. And then, this is really, really interesting, guys. What we do is we pump water up out of Twin Lakes into that little extra lake when we have extra electricity. And when we need electricity, we let the water flow back into Twin Lakes, and it turns a turbine and it makes electricity. So when we have extra electricity, we pump the water up into that lake. And when we need electricity, we let the water flow down through a turbine. So we're using that lake as a battery. We're using that lake as a battery. So it's a wonderful example of energy in Colorado, innovative use of water to store power. And the reason is that sometimes we have excess electricity, like when people aren't using very much, and let's say the wind's blowing really hard. And then there's sometimes when we need more electricity. For example, if there's an evening and the wind's not blowing too hard, we need electricity, and we can get it from letting the water flow back down and turning the turbines. So what we're going to do now is we are going to consider the power of ice, and we've got a little video that Mitch put together, and let's talk about the power of ice.
So just how powerful is the expansion of ice as it freezes? Do you think it's powerful enough to break apart this galvanized iron pipe? Well, let's find out. Now, obviously, it's not cold enough here where I am to freeze this pipe, but I have something that is very, 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 very cold, and that is liquid nitrogen. So this container is full of liquid nitrogen, which at this altitude is about -320 degrees Fahrenheit. What you can see as I pour it, it's boiling like crazy because this room temperature container is about 400 degrees hotter, and you have this cool cloud forming as all the water vapor in the air condenses. Now we're going to take this metal pipe and we're going to fill it with water and put in a plug so the water can't possibly get out. And I want to be careful. I'm going to screw the plug in the water because I don't want to get any air in there, because air can actually compress, and so it will undermine our awesome experiment. There's no telling what will happen here. It could expand and cause a little crack. It could expand and blow apart a whole side of this elbow. It all depends on this particular elbow and what its weak points are. Even though it's all galvanized iron, somewhere in there is going to be slightly less strong than the rest of the pipe. Okay, so I have my safety trash can here. I'm going to put the liquid nitrogen in there. Then we're going to put the pipe elbow full of water in liquid nitrogen. And then everybody hide! Whoa! Oh! Okay. That sounds like something happened in there. Let's see what happened to our metal pipe. Oh, there we go. Got a crack right in the metal pipe. You can see the the side there has bulged out. It's actually cracked through this metal pipe, which looks like about 1/2 inch thick to me. That's amazing. This is a galvanized iron pipe, and ice, just water freezing, was able to break it. And this is something, people have been doing this kind of experiment for years. Back in the 1700s, some scientists filled a cannon with water to see what would happen. And also our container felt some of the damage of that explosion as well. So that's pretty amazing. Freezing ice, powerful enough to break apart iron.
So thank you, Mitch. That was an interesting experiment. And again, what he did is he put the water inside the pipe, and then he froze the pipe using liquid nitrogen, and the force of the expanding ice was strong enough to break that metal pipe. If we think about Colorado and we think about ice in the wintertime, you have to think about water seeping into the little cracks in the rock. And there's a nice warm day, the rock is wet and the water seeps into all the little cracks. And then at night it freezes. And when water freezes and turns into ice, it expands, and that can actually break the rocks apart. And a lot of the mountaintops in Colorado, if you climb up onto the tops of Colorado's mountains, you'll see that you've got tremendous cracked areas, all kinds of broken rock, fractured rock. And that is the results from the freezing and thawing, which happens again and again. You know, you think about it in the wintertime, every night it's super cold, every day it warms up a little bit, and the rocks actually are broken apart by this same force that Mitch was showing us. Now we're going to back out from Colorado, and we're going to look at some more ice, and we're going to go again up north. We're going to go further north, and we're going to head up towards Greenland. And I just want to show you some of the big icy places on the planet. And Greenland is a place that's not very green. It's really covered in ice. We'll see that in a few minutes. I always think that some Viking like Leif Erikson or one of his family was trying to attract their other friends to come, and so they named it Greenland. It's not very green. There were some settlements there, and there are still people living in Greenland, but it's a pretty frozen place. You'll see it coming into view right at the top of the screen, and it's a big island, and it's covered with over 1 kilometer of ice. The ice is over 1 kilometer thick, about 1,300 meters thick. And it's a tremendous pile of ice sitting on top of Greenland, and it's melting. So every year, a little bit of that ice melts. And as it comes off of Greenland, it flows into the ocean, and the sea level is starting to rise. We'll show you a graph here in a minute about the sea level, but let's look at some of the glaciers coming off of Greenland. It's a super interesting feature. And again, these are rivers of ice flowing off of the Greenland ice cap, and they're flowing right into the ocean. And when the ice comes into the ocean, what do you think it makes? I'll let you think about that for a second. The ice is flowing into the ocean. The glacier is flowing right into the water, and it breaks up as it comes into the water. What do you think it makes? I'm looking at the chat to see if people come up with what it's going to do. And I think if we get close enough in, we might see, there it is. I see people getting it. There you go. It makes icebergs. And these icebergs can be very dangerous to ships, because the ships are sailing across the ocean and suddenly they can hit the iceberg. And there are some famous examples of ships that have sunk because they hit icebergs. And some of you might know about the story of the Titanic. And the Titanic was a very huge and immense ship, and it was sailing on its maiden voyage across the Atlantic, and it hit an iceberg that came from Greenland, and it sunk. It was a very dramatic story. And my grandmother knew people who were on the Titanic. It's an interesting story. So we're coming in close. We're looking at some of the character of the ice here around Greenland, and the computer is sort of patching in different images as we get closer. And Google Earth will do the same thing. You guys can go to Greenland using Google Earth, and you can see some of the ice in Greenland. So here there's two different images. One is wintertime and one is summertime, maybe. And As we get closer, we're turning into the summertime image, so we can see the blue open water, but you'll still see icebergs. I think we'll get up there, we'll see some icebergs. I think we're seeing some icebergs right now. Those are, yeah, so see those icebergs? So the icebergs, of course, are floating pieces of ice on the sea surface. And if you're in a boat, you've got to be super careful about these icebergs. But they reflect the fact that the island of Greenland is melting. Every summer it melts, and it's losing ice that's going into the water, and sea level is rising. And we might, Talia, let's just take a quick look at the sea level rise curve. And I'll just show you a quick graph that shows what sea level is doing. And this is a graph that goes back into the 1880s, but it comes, the time is on the bottom from old on the left to young on the right. And then the sea level is shown in millimeters going up. And sea level, you can see slowly rising, systematically rising. It's rising about 3 millimeters a year, which is a little bit about the thickness of a penny. And that might not seem like very much, but I'm a geologist, and 3 millimeters a year adds up. Every year you get a little bit more. And if we made a stack of pennies, let's say that each year is a penny, and if you stacked up 10 pennies, that's a pretty good stack. If you stack up 100 pennies, let's say about a human lifetime, some of you might live to be 100 years old. That'd be a wonderful thing. You should try to stack up 100 pennies sometime. Not an easy thing to do, but that's how high sea level would rise in your lifetime if it keeps on going at this current rate. And of course, lots and lots of people live very near sea level in places like Florida, places like New York City, places like San Francisco. And so those people are going to have a hard time as sea level rises. And you guys will face that over your lives because sea level is rising, of course, around the whole world, and people will need to move away from the coasts. And it's already happening in places like Florida and some of the islands in the South Pacific. So we can pop out now, Asa, let's pop out from Greenland and let's go look at Iceland, which is another really interesting place right nearby. We're going to go look at Iceland. And I've spent a lot of time studying Iceland because it's a fantastic place for geologists to look at geology. And we're going to go over to Iceland, and you'll see that it's a smaller island, of course, than Greenland, but it's a little bit greener. So Iceland is called Iceland, but it's greener, and Greenland is called Greenland, but it's icier, whiter. This is the island of Iceland, and it's made of volcanoes. There's a wonderful variety of volcanoes, and the tallest volcanoes have ice covers on them, glaciers on them. And when there's a volcanic eruption underneath the ice, it's super dramatic. What happens is you don't see anything at the surface. You can sometimes see a little steam come up, but then what it's doing is it melts the glacier, and you get a huge bubble of water that comes out underneath the glacier, and it comes roaring down through these valleys on the lower part of the screen. And you get these tremendous floods associated with erupting volcanoes underneath the ice. Iceland is the land of fire and ice, and it's an absolutely wonderful, beautiful, beautiful place. And I've had some wonderful trips to Iceland to study glaciers and to study the volcanic rocks. And we can zoom in here. Let's go look at these glaciers that are coming into this pond. And this is a wonderful place to go visit. When you go to Iceland, I encourage you to travel to this place. And you can get to Iceland from Denver. There's a flight that goes from Denver to Iceland. So someday some of you guys will be able to get to Iceland and see what's going on. It's a place where puffins live, a beautiful little bird called a puffin. And this is, we're looking at a place where glaciers are flowing into a little pond or a lake. And we're going to see the shortest river in Europe. Iceland is technically part of Europe, and the shortest river in Europe is going to come into view here in just a few minutes. You might see if you can spot it as we're coming in. Keep an eye out. You're looking for a very short river. And I see people asking for videos of this. We don't have videos of the Iceland glaciers yet, but we might be able to get them someday and share them with you. But you can see these glaciers are flowing down into what's really a lake, and then there's an outlet from the lake into the North Atlantic Ocean. And there's a bunch of icebergs in that lake that are trying to get out. And I think you'll see that if we can sort of get the view here. Now we zoom in, I think you'll see there's a bridge actually crossing this river. And this river is so short that you could walk the length of that river on your lunch hour. I mean, over lunchtime. But there's a bridge across it. And if you go to Iceland, you can drive around the island and you'll cross this bridge. And you'll be able to see the icebergs in the lake. It's got beautiful little icebergs. That's the bridge there. Asa's showing you the bridge. It might pop into there. It has better resolution. There you go. You can see it a little bit better. So this is a bridge across the shortest river in Europe. And you can see all those icebergs that are just ready to come out. And they flow out every once in a while. And you'll see there's a little village there. It's not really a village. It's a little hotel. And you can rent boats. And if you go here, you can rent a boat and you can take a boat out into this pond and see the icebergs. These are little baby icebergs. They're not very big. You can see the cars for scale there in the parking lot. So these icebergs are the size of a school bus or maybe a football field. Beautiful icebergs here in Iceland. Now we're going to have another poll coming up, so I'll give you a bit of warning here. We can, using this tool, this open view tool, we can go, open space tool, we can go anywhere. We can go anywhere in the world. And what I'd like to do is offer you guys the choice of going to the highest mountain in Africa or the highest mountain in the world. And the tallest mountain in Africa or the tallest mountain in the world. And each one of them has ice on them. So we'll take a few minutes as we talk about Iceland, and you guys choose whether you want to go to the highest mountain in Africa or the highest mountain in the world. And as we look at Iceland here, you'll see that there's a variety of different big glaciers. Iceland is a country that has a wonderful tourist industry, and they also have a lot of energy. Iceland is like an energy island. They have geothermal energy coming from hot rock. They have hydroelectric energy coming from the rivers that are coming from the melting glaciers. And that's a wonderful illustration of people using their imaginations and their skills and engineering skills to create renewable energy. And if you travel around the world, you'll find Icelandic engineers in many different places working on particularly geothermal energy programs. So I see the poll has closed and Everest is the winner. So it looks like it was 178 people wanted to go to Everest and 65 people wanted to go to the highest mountain in Africa, which is Mount Kilimanjaro. And let's go to Mount Everest first. But actually, Asa, let me think about this. You know, I really wanted to show you Kilimanjaro, and Kilimanjaro is sort of on the way to Mount Everest. So why don't we'll take a quick peek at Kilimanjaro, and then we'll scoot over to Everest. So we're going to take a quick peek at the highest mountain in Africa before we go to your first choice, which is Mount Everest. And the reason I wanted to show you Kilimanjaro is because I've actually climbed up on top. And so it's a place that I love very much. I still do a lot of work in Africa. And Kilimanjaro is a volcano and a wonderful place for geologists to visit. And two of my friends and I climbed up to the rim of Mount Kilimanjaro when we were students, not much older than you guys. Some of you guys, we were just out of college, and we climbed up to the top of Kilimanjaro. And there's not much air up on the top of Kilimanjaro. So you got to go a little bit south. It just went out the south end of the screen there. So that's just right there. Yep. And Kilimanjaro is a huge volcano sitting on the border between Tanzania and Kenya. It's actually in Tanzania. And beautiful country with, on the plains around Kilimanjaro, there's lions and warthogs and giraffes and hippopotamuses It's a fantastic place. And then you climb up the mountain, you slowly climb through the forests. There are all kinds of interesting birds and little animals that are hiding in the woods. And then you keep on climbing and it gets higher and drier and colder. And pretty soon there's no more trees and it's almost like a tundra. It's like high tundra. And then you keep on climbing. And at the very top of Mount Kilimanjaro, there are glaciers. And they're small because they're melting. These glaciers are melting pretty quickly. And some in the not too distant future, the glaciers will be gone from the top of Kilimanjaro. There'll still be snow in the when it rains or snows because it's so high up, but the snow melts and the glaciers are melting. So we're losing the water from the top of Kilimanjaro. But here you can see, if we can get in a little closer, I just want to show you that it has a crater on the top, and there's actually sulfur and hot gases coming out. I'm not sure, the computer's a little slow here loading it up, but it should pop and show us a crater. And you can do this on Google Earth. If you guys go to Mount Kilimanjaro on Google Earth, you'll see it very nicely. And I can see it's starting to pop in here. They said we've got to just be patient. There, it's coming there. And you can see there's a circular feature, and it's actually an active volcano. And someday it's going to erupt someday. We don't know when, but it will erupt. And you can see, maybe if we look at it obliquely, step back a little bit, this view is a little bit tough because it's just not popping in. But there is a crater. And if you go to Google Earth, you can get yourself right into the crater on the top of Kilimanjaro. I think, let's see, it's just not focusing in very well. I think, Asa, let's back out, and we should really respect the choice of the people. And why don't we back out and we'll head over to the Himalayas, and we'll see what we see there. You can see a little bit better. I just want you to see Kilimanjaro. It's a really, really beautiful mountain, a wonderful mountain. If you ever get to Africa, take a look at Kilimanjaro. It's one of the most beautiful mountains, especially if it has a warthog in the front. If you're down in Kenya and you put a warthog in the view, it makes a magnificent background for the warthog. I could show you some slides sometime. Someday I'll show you guys my slides. Slides are what we used to call pictures before we had telephones. Here, this is, we've come over to India and Pakistan, and the Himalaya mountains, which many of you have heard of, are the highest mountains in the world. There's a whole series of super high peaks, and the highest mountain of all is Everest. And Everest, I'm seeing somebody ask in the chat how tall it is, and I have that answer somewhere near me. Let's see if I can find it. Well, you guys can find out how tall Everest is faster than I can. So there's no questions, there's only answers. So somebody will put in the chat how tall Mount Everest is faster than I can find it, because I wrote it down somewhere. I did, here it is. Oh, let's see. It's over 29,000 feet. I've got K2. Anyway, so here is, this feature is where Mount Everest is located. There it is. Somebody's put it in the chat, 29,032 feet. It is super high. And some people think it's 2942. So hard to measure the height of Mount Everest. You can picture that that's not an easy thing to do. And here, it's right in the middle of the screen, and there's glaciers flowing from all sides of Mount Everest. It's a super high mountain, and the moist air from the Indian side, the south side, precipitates. It's called the monsoons, and they get a huge amount of snowfall up on the top of Mount Everest, and it makes all these glaciers. You can see glaciers coming off on all sides, and it's flowing to the north up into Tibet, flowing from the south into Nepal, and Mount Everest sits right on the border. That's the border. Tibet is now controlled by China, so it's on the border between China to the north and Nepal to the south. And you can see the rivers of ice flowing in all directions. And of course, those rivers of ice are carving that mountain. That Mount Everest is part of the reason it's hard to tell how tall it is, because it's being eroded by the erosion of the ice and the snow and the freezing in the winter. Well, of course, it's freezing all the time up there, and the mountains are slowly being eroded away, but they're also growing at the same time. These mountains are growing because India is plowing to the north into Asia because of continental drift. And so Mount Everest and the mountains all around it are still growing. So the forces of geology are making them go up, and the forces of erosion and ice are making them go down. And so there's a dynamic interplay between these two forces that result in the carving of these mountains. And you can just see how the cliffs are so steep, and there's avalanches and ice falls and tremendous challenges for people that are hiking or climbing in this area. If you read about the hikers and climbers on Mount Everest, you'll hear about the Kumbu Ice Fall, one of the most treacherous places of all. And many people have lost their lives trying to climb Mount Everest. It's made of sedimentary rock. I can see the layers of sediment right here. And when they climb up to the top of Mount Everest, and I've never done this, but I have friends who have, they didn't get quite to the top, but they said there's sedimentary rocks up there that have fossils of ocean, there's seashell fossils up on Mount Everest. So the highest mountains in the world are made up of sedimentary rocks that were formed below sea level. And that's the force of continental drift and plate tectonics that are making that happen. So what we're going to do now is we're going to pull ourselves away from the Himalayas. We're going to leave these exotic territories. And I want to bring you back to Colorado. So what we're going to do is we're going to slowly pull ourselves away from the Himalayas. We might make a few comments as we travel. And we're going to be aiming to come back right to the Denver Museum. And we're going to bring you back to your school bus, which is parked out in front of the Denver Museum, and get ready to return home. But before we do that, we'll have a chance for some questions and answers. So Ace is going to...
Bob, do you mind, we actually have a question about the Himalayas while we're flying away.
Sure.
You mentioned the mountains are still growing. How do mountains grow?
Mountains grow dramatically. I mean, it's huge. Mountains, they're almost like living things. I mean, the mountains, I've studied the Himalayas for my thesis, so you're asking a question that's dear to my heart. And the plates on the surface of the earth are moving at about the rate that your fingernails grow or your hair grows. So the plates are drifting around, and when they smush into each other, we call it collision. When they collide with each other, they make mountains, and those mountains are growing. And so the Himalayas are growing. The mountains in California, some of them are growing. The mountains in South America are growing. So mountains change through time. And of course, at the same time they're growing, they're being eroded away. So it's this, the Earth's surface is this dynamic interplay between mountain growth and erosion. And Colorado, we see a lot of that. You see erosion wherever you look in Colorado. Some of our mountains are very old. They were made millions of years ago, and they're slowly eroding away. And every year, if you go and look at the rivers, you'll see there's mud in the rivers, there's pebbles in the rivers, and that's because the mountains are slowly eroding away.
Very cool. And we had a lot of questions asking if we could go inside of a glacier. And we should have mentioned this earlier. All the images you're seeing are taken from satellite photos. So these are real photographs of the Earth put together. But Bob, what would it look like if you could go inside of a glacier?
Well, I've been inside a glacier. So I was in a glacier in Iceland, and at the very bottom of it, there was a hole where a river was coming out, and we walked inside the glacier. And it's super amazing. The light is very blue, and of course it's dripping water everywhere. Everything's wet because it's melting. And so you're in a blue, wet kind of place. And it's a very exciting thing to do. If you get to the foot of a glacier, sometimes you can find a little place where you can go inside it where the river is coming out.
Amazing. We also had a lot of people wondering when we were looking at the Taffy Glacier and the Caterpillar Glacier, are there any animals that live around those glaciers?
Oh, absolutely. So for example, there are, I've been on glaciers where there's lots of insects. I mean, surprisingly enough, on the ice surface, you'll see lots of bugs flying around, and there's actually some kind of algae that turns the glacier pink. There's something, it's called pink snow, and it's some kind of algae. So there's plants and animals that live on glaciers. Now, it's a pretty extreme environment. There's not a lot to eat there, so they don't live there their whole time, but they do hang out on glaciers. You'll find critters there for sure.
Very cool. And this is maybe a basic question, but maybe a complicated one. What makes something a glacier?
So the question is, what makes a glacier? And that's a super important thing that we spend a lot of time thinking about. And if you go to Rocky Mountain National Park, for example, if your parents can take you to Rocky Mountain National Park and you go up on Trail Ridge Road, if you get up on Trail Ridge Road in Colorado, which is just west of Fort Collins, you'll see it's super cold up there, and the snow comes down in the wintertime, and a lot of times it doesn't melt. It stays there all year long. And if it's cold enough that the snow doesn't melt in the summer and it keeps accumulating in the wintertime, you'll get an accumulation of snow, and eventually you'll get enough snow that it'll form a solid block of ice, which becomes a glacier. Now in Estes Park and in Rocky Mountain National Park, the wind is super important because the wind is blowing from the west and it carries more snow across those ridges and deposits it on the east side. So we had a whole series of glaciers on the east side of the Continental Divide in Rocky Mountain National Park. There were a combination of the wind bringing the snow and the snow falling out of the air and coming together to form a solid block of ice that got big enough that it was able to flow.
Very cool. This one is actually for me, which is what happened to that cannon that scientists filled with water and left outside, and the ice froze and the cannon itself cracked. So even bigger metal things can be defeated by the expanding power of ice.
No, absolutely. Yeah, no, and the ice is a hugely powerful agent, and we don't think of it necessarily as very powerful. If you look at an ice cube, you might say, well, that ice cube's not very exciting, but if you think about what it can do, slowly but surely, it can move mountains. It's unbelievable.
Amazing. And we had some people wondering, what is the oldest glacier and what is the biggest glacier?
So that's a super good question. The biggest glacier, or the biggest ice mass on the surface of the Earth, is Antarctica. And that's also the oldest. Right now, we think that the oldest ice on Earth is in Antarctica. We've drilled cores down into the ice in Antarctica. It means we've gotten samples of the ice. And the ice has layers in it. And you can see the layers and count them. And every layer is a year, just like tree rings. And the layers of ice in Antarctica go back almost 1 million years. So the oldest ice in Antarctica is about 1 million years old. The oldest ice in Iceland is about 180,000 years old. So in Greenland. So the oldest ice in Greenland, about 180,000 years old. So nowhere near as old as the ice in Antarctica.
And a follow-up to that, have they found ancient animals or fossils in the glaciers?
Oh, absolutely. In fact, if you go to Wyoming, there's a wonderful example in Wyoming. There's something called Grasshopper Glacier. And there was some kind of grasshopper infestation way back hundreds and hundreds of years ago. And they flew across the Wind River Mountains and they got hit by a snowstorm and they fell onto this glacier and they got incorporated into the glacier. And there's a layer in Grasshopper Glacier that is made up of grasshoppers. Now there's other places where you find woolly mammoths and things like that coming out of frozen ground. Sometimes they're not in glaciers, sometimes they're in the frozen ground near the glacier. And then the other thing that happens is as the glaciers are melting, you can find evidence there's archaeological evidence and fossils of animals and plants in the ground that's being revealed by the melting glaciers.
So cool. That's amazing. There's a layer of grasshoppers. And we also had other questions. You talked about that those lakes being used as a power plant or a battery, but how does that work?
Well, so that's a very good question. And one that, as you young people are looking for careers and looking for opportunities, of course, I'm a science kind of guy, and I encourage all of you to take science classes and study science because we're going to find answers to many of our challenges through science. And climate change is a very, very significant challenge for you, young people. It's going to be something that's going to be affecting your entire lives. And you're going to be trying to find renewable energy. You're going to be trying to find more efficient ways of using electricity your whole life. You're going to spend your entire lives looking at ways to make the earth a cleaner place, a better place, a happier place for your children. And yeah, you're going to have children. So think about it. The way we use that as a battery is when we have extra electricity, meaning when there's available electricity. Let's say the wind is blowing super hard in the middle of the night and nobody's using too much electricity, but the wind is still super blowing. Well, what do we do with that electricity? Well, we need to do something with it. We need to store it. And so one of the things that we do with it is we pump water from Twin Lakes up into that extra lake up on the top of the hill. We literally pump the water. We use the electricity to pump the water up high into that upper lake. Then a few days later or a week later, when we need electricity, when the wind stops blowing, for example, we can let that water flow back downhill through turbines, through generators, and it makes electricity. So we're essentially storing the energy, as we call it potential energy. We store that energy in the water by raising it to a high point and then letting it flow down.
That's so cool. So just using the power of gravity.
Yeah, exactly right. We're using the power of gravity. That's potential energy. That's exactly right.
All right, well, that's about all the time we had today. Thank you so much for joining us from all over the country. This was very exciting. We had a great time. I hope you did too.
Let me just put in a plug for, this is a new program and we're going to be running these, every month or so. So if you like this program, we've got a program coming up that's going to look at the Earth and see if you were an alien visiting the planet Earth, we're going to try to determine whether you think it might be inhabited or not by looking at it from space. So that's a program that's coming up. I'm just putting a plug in for the future.
Yeah,
program.
absolutely. We hope to see you again in about a month or so. So thank you again, everyone. Thank you so much and have a wonderful day.
Thank you all.